Imagine a world where objects can be in two places at once, where particles communicate instantly across vast distances, and where the very act of observation changes reality. No, this isn't science fiction. It's the mind-bending realm of quantum physics, and it's happening all around us, right now. Welcome to the quantum world, where the rules of classical physics break down, and a new, bizarre reality takes over. In the next 8 minutes, we're going to dive into this microscopic universe and explore its mind-boggling phenomena. Buckle up, because things are about to get weird. Let's start with the basics. Quantum physics deals with the behavior of matter and energy at the molecular, atomic, nuclear, and even smaller microscopic levels. At this scale, the classical laws of physics that govern our everyday world simply don't apply. Instead, we enter a realm of probabilities and uncertainties. One of the most famous and puzzling aspects of quantum mechanics is the concept of superposition. In the quantum world, particles can exist in multiple states simultaneously. It's like a coin that's both heads and tails at the same time, until you look at it. This idea was famously illustrated by Erwin Schrödinger's thought experiment, known as Schrödinger's cat. Imagine a cat in a sealed box with a vial of poison that may or may not be released based on a random quantum event. According to quantum mechanics, until we open the box and observe the cat, it exists in a superposition of states, both alive and dead at the same time. It's only when we look that the superposition collapses into one definite state. Now, you might be thinking, that's absurd. How can something be in two states at once? And you'd be right to be skeptical. Our everyday experience tells us this is impossible. But in the quantum world, it's not only possible, it's the norm. This leads us to another mind-bending concept: wave-particle duality. In quantum physics, everything, light, electrons, atoms, can behave as both a particle and a wave. It's as if a baseball could suddenly stretch out into a ripple across a pond, or an ocean wave could suddenly ball up into a single point. The famous double-slit experiment demonstrates this perfectly. When scientists fire individual particles at a screen with two slits, they create an interference pattern as if waves had passed through. But if they observe which slit each particle goes through, the interference pattern disappears and the particles behave like, well, particles. It's as if the very act of observation changes the nature of reality. But wait, it gets even stranger. Let's talk about quantum entanglement, a phenomenon so bizarre that Einstein called it spooky action at a distance. When particles become entangled, they form a connection so intimate that you can't describe one without describing the other, no matter how far apart they are. Imagine two coins that always land on opposite sides, even if they're light years apart. Flip one coin, and the other instantly flips to the opposite side. This isn't just a neat trick. It's a fundamental aspect of quantum mechanics that could revolutionize computing and communication. Speaking of computing, quantum mechanics is poised to transform the world of technology. Quantum computers, which harness the power of superposition and entanglement, could solve complex problems in seconds that would take classical computers millions of years. From developing new medicines to optimizing financial models, the potential applications are staggering. But quantum mechanics isn't just about future technology. It's already a part of our everyday lives. The GPS in your phone relies on incredibly precise time measurements that account for relativistic effects predicted by quantum theory. The transistors in your computer's processor work based on quantum tunneling. Even the sun's nuclear fusion, which provides the energy for all life on Earth, is a quantum process. Now, you might be wondering, if quantum mechanics is so fundamental, why don't we see these strange effects in our everyday world? The answer lies in something called decoherence. As quantum systems interact with their environment, they quickly lose their quantum properties and start behaving according to classical physics. It's like trying to see a candle flame in broad daylight. The quantum effects are there, but they're drowned out by the classical world around them. Despite over a century of study, quantum mechanics still holds many mysteries. Scientists continue to debate the interpretation of quantum theory, grappling with questions about the nature of reality itself. Is the universe deterministic or inherently random? Do parallel universes exist? These questions push the boundaries of physics and philosophy alike. One thing's for certain: the quantum world is far stranger and more fascinating than we ever imagined. It challenges our intuitions, defies our common sense, and yet underpins the very fabric of our reality. From the smallest subatomic particles to the vast expanses of the cosmos, quantum mechanics shapes our universe in profound and unexpected ways. As we wrap up our whirlwind tour of the quantum world, remember this: every atom in your body, every photon of light that hits your eye, every electron flowing through your neural circuits as you process this information, they're all dancing to the bizarre tune of quantum mechanics. The next time you look in the mirror, consider that you're not just observing yourself, you're collapsing wave functions and resolving quantum superpositions. In a very real sense, you are a quantum being, intimately connected to the strange and wonderful quantum realm that surrounds us all. And that, perhaps, is the most mind-bending realization of all.